Okay, right. Yeah, so welcome to the session. I'm very happy to have our speakers here today. So we'll have a short recap of each, and then turn it over to questions. So let's see. So I guess our first speaker. I'm sorry, I was a little bit disorganized because I was trying to figure out how to get logged in. Yes, John McCool, Chief Scientist at Raytheon BBM Technologies, who has a long distinguished career in speech recognition, fellow of the IEEE, International Speech Communication Society, and Acoustical Society of Engineering, who will talk to us about the dawn of benchmarking. John?
Okay, so I need to share my screen, right? Let's see here.
And while he's working on sharing his screen, I might just point out that I've had access to data on page views, and his talk here is the top of the list by a mile. So I encourage you to go listen to the whole talk.
Thank you very much for that plug. The talk is there, and I have my whole presentation is also there, the slides. I've shortened the presentation here. I don't know if I can do it in 8 minutes, but let me at least, okay, let me try. See what I can do. Let's see, where am I? Now I was there and I lost it. New share, is that what do you see?
It is being shared. It's just not in.
It's being shared.
Okay,
yeah,
perfect.
It's just not in. Now it's wonderful.
Now it's good.
Excellent, wonderful.
Okay. All right, very good. Oh no, I have to learn that I cannot do space. There's a bug in this in this system that I cannot use the space bar to go to the next slide. Okay, there's always been a desire to benchmark, and you go back in history and always but in our field, in human language technology, I would say that 1987 was a key year, especially for speech recognition, in which benchmarking really started. And this was due to the confluence of several factors. The first three are necessary. The insistence on benchmarking by somebody, like the government, by having a common corpus and a defined metric. That's straightforward. But what really exploded the whole area of benchmarking is the use of trainable systems, wide participation, which resulted in the acceleration of the technology, which created a positive feedback loop, and it just mushroomed from there. Now, I'll just summarize. Early on, around 1970, there are two different reactions to why speech recognition ASR is difficult. And John Pierce said that this is not ASR is not possible unless you can understand speech the way a human does. Since that's not possible, therefore speech recognition is useless. Don't work on it. And he stopped all work at AT&T. Okay, it didn't get restarted until a decade later. Now, the ARPA contractors said we agree that you need higher level information, including syntax and semantics, but we know how to do it. And so they proposed a 5-year program to work on this, and ARPA at the time became DARPA later. Started the Speech Understanding Research Program, 1971 to 76. Now, it was a 1,000-word vocabulary continuous speech. Almost all the methods used for speech recognition were what you would call heuristic method, knowledge-based, rule-based, methods, including at CMU, including BBN, and everywhere else. There was only one exception. That was Jim Baker had his PhD thesis was the Dragon system, Now, it was based on what we later started calling HMM. They were not called hidden markov models yet. Okay, so I will talk about, more about that. But the advantages of his approach were totally lost on most people, including me. Okay, I have to confess, and Raj Reddy, who was in charge of the program at CMU, and the government everywhere. Okay. But this program, only the simplest task could be done with good enough success and reasonable amount of time. What was called as a branching ratio, a small branching ratio. How many words can you follow a particular word? And this was a new concept actually that was created in that program. So it gets credit for that. And there was a very good work in syntax and semantics, but it really did not help a whole lot at that time. And when Heilmeyer came as director in 1976, he said, and he's a components person, he said, if you cannot do it in real time on a machine, it's not worth doing. So the recommendation to continue the program was said, no way, we're not continuing this effort. And basically, all work in speech stopped for about 8 years. In parallel with all this is going on, mathematics of what's called probabilistic functions of a Markov chain in the late 1960s at IDA in Princeton were being developed, and they finally held a workshop on that in 1980. And this was the very first use of the term hidden Markov models. It was never used before. And right after that workshop, which included only about 40 people invited, the work at AT&T started right away. We followed later on, and IBM had already started work in that area actually before, and Jim Baker had joined IBM, but Jelinek and group were working on that technology totally independently for a different reason. They also, IBM gets a lot of credit because they had this information theoretic approach. Like we use now today the word decoder and perplexity. These are concepts that were laid out at that time by them, and we continue to use those terminology. And eventually, what people settle on is statistical language models, for speech recognition. Now, 8 years later, after the first ARPA program, DARPA now started another program called strategic computing, and part of it was speech recognition. And they held semi-annual speech recognition workshops starting in 1986. What was important here in this program is that Alan Sears, the program manager, insisted on common evaluation. Okay. And the definition of corpora, of benchmark testing, how to test, what's training, what's test, what's the metric, all that was done by the community of that program. So that was really an important development. And in 1986, they defined, and two different corpora they collected, the TIMIT, which continues to this day, actually. People use it for acoustic phonetic research, and the resource management corpus, which a very, 1,000 word vocabulary, but, a couple of thousand sentences, nothing huge, but at that time it was big. Okay. And as far as metrics are concerned, that first year, they said, okay, percent word correct, that's all we're going to report, nothing else. And the first common evaluation was in March 1987. Only 2 teams participated in that evaluation, CMU with a knowledge-based approach, rule-based approach, and BBN with HMN. By the way, CMU won the big contract, and we were handed out just a small amount of money, but it was enough to build a system with HMM. And there was no question that HMM system was far better. And as you know by now, it is good reasons why. And automatically trainable, does not require expert knowledge, only annotated data, much simpler to build. And what's very important is that the new techniques are easily transferable to other people, so they can copy what you just did and improve on them. And what they used to say that, the statistical methods are no good because they cannot model phonetic distinction, that was no longer viable. But they said, well, maybe these knowledge-based methods can do better in locating word boundaries. All right. So there was another test held that year to actually, and there were people annotated word boundaries, believe it or not, okay? And actually say, okay, did you get that word boundary correct? And again, HMM was better, even though it was not trained to do that specifically. And by the following year, CMU had shifted completely to statistical models and HMMs. And the community settled on the word error rate that's still in use today. You all know, what this error rate is. And following that, there was a whole bunch of other new DARPA programs, actually. And I have to credit Charles Wayne for continuing the push for common evaluations that Alan Sears had started. And Charles gets a second, credit for he was the one who proposed, and I think, Mark knows all of this, and he will talk about that, I hope, to fund the Linguistic Data Consortium, which was housed at the University of Pennsylvania in 1992. And Charles provided the seed funding. I believe it was like $5 million at the time. And that was the takeoff. And it was LDC, I would say, one of the most important developments in our technology, for sure. No question about it. So there were other corpora, other evaluations with greater participations. Oops, I did the same thing again.
Okay, that's great. Are you about done, John?
I'm almost done.
Okay, because we're at 10 minutes. So do want to allow.
The success of metrics-based evaluation, common corpora automatic trainable systems caused acceleration of progress worldwide, and the paradigm spread to other fields within and outside DARPA. Now, word error rate was easy to define. Other metrics, as we know, are much harder to define. And this was the last slide that I was going to plea for corpus creation is to do more annotated corpus, to measure inter-annotated agreement. I already made that point, so I'm done.
Excellent. Okay, thanks. Well, thank you for that great summary of an hour-long talk or a 45-minute long talk. Let's go on to Mark Lieberman. And again, another researcher who needs no introduction, head of the Linguistics Research Department at AT&T Bell Labs, founder of the Linguistic Data Consortium, and professor at the University of Pennsylvania.
Sorry, I was muted. My video was off. Now I can share my screen and start the presentation. Okay, so what I have to say overlaps a great deal with what John had to say. But I'm going to start, since I was originally trained as a linguist, by going to the Oxford English Dictionary to define benchmark, which is a fixed point used by surveyors. And the mark takes the form of a horizontal groove into which the upper surface of an angle iron would have been inserted, forming a level surface or bench. But the relevance here is the figurative extension, a point of reference, especially one from which measurements can be made, something that serves as a standard by which other similar things may be measured or evaluated. So what are these figurative benchmarks for? Well, for selling stuff. Our chip is the best, our whatever is the best, our system is the best. Buying stuff, which system should we choose for this task? Process planning, how much X do we need to do this? Process management, how much X are we using to do this? Education, which students have learned what, and so on and so on and so on. But as diverse as they are, those benchmarks all aim at near-term action. We're going to buy something, we're selling something, we're planning something, we're evaluating a process in some ongoing practical situation. And there's a different kind of benchmarking that played a crucial role in the history of human language technology. These days, human language technology is more and more widely used. It's quite practical. There are 4 secrets to its success and its practicality. There are obviously better algorithms. John talked about one sea change, the change from hand-coded algorithms to HMMs. Obviously, other things have happened since then. Cheap, fast digital hardware, ubiquitous digital networking, but there's also, as John indicated, a research management technique that was developed in the 1980s. Of course, it had really been used before that by some people, but as a technique for managing government-sponsored research, as far as I know, it was new then and applied increasingly widely since then. The third one, it's worth learning about the history, although the idea has been very broadly accepted. And this idea was what came to be called the common task structure, which requires a detailed task definition and evaluation plan, which is developed in consultation with researchers and published as the first step in the project. There's automatic evaluation software written and maintained by a neutral third party, also published at the start of the project. Crucially, there's shared data, training and dev test or development test data, which is published at the start of the project. Evaluation test data is withheld for periodic public evaluations. So why did it work? Well, it allowed funding to start. That is, people who were skeptical about throwing good money after bad on what some people felt was a fruitless endeavor, a problem that couldn't be solved, at least at that time. But it allowed funding to start, and it allowed funding to continue because the funders could measure progress over time. Less obvious is that it allowed project internal hill climbing because the evaluation metrics were automatic and efficient, the evaluation code was public, and researchers who initially had objected to being tested twice a year began testing themselves as often as they could rerun their system. Least obvious was that it created a culture because researchers shared methods and results on shared data with a common metric. Everybody became, you might say, foxhole buddies. And participation in this culture became so valuable that many research groups joined without funding. It also created a positive feedback loop because when everybody's program has to interpret the same ambiguous evidence, ambiguity resolution becomes a sort of gambling game. Statistics was originally developed to model gambling, and so this rewarded the use of statistical methods and led to the flowering of machine learning. Given the nature of speech and language, statistical methods need the largest possible data set. As they used to say, that the best data is more data, which reinforces the value of shared data. Some earlier talks pointed out that more data is not always the best. There are other criteria, but more is always better. Iterated train and test cycles on the gambling game are addictive. I think people actually literally get a dopamine hit if you were to measure it from that. This creates simple, clear, sure knowledge, which motivates participation in the common task culture. So this has become the standard research paradigm in what we might call experimental computational science. Published training and testing data, well-defined evaluation metrics, techniques to avoid overfitting, and this applies to any sort of algorithmic analysis of the natural world. Versions of this model are now routinely used outside of sponsored projects by academic and industrial researchers. Challenges are routinely created by technical societies, ad hoc groups, and even individuals. I want to note in passing, as Brian and others have observed, there's some important areas that are lagging far behind, both in technology and methodology. Clinical applications, educational applications, to some extent legal applications, and a cultural change in those fields is really long overdue. As AI and human language technology has advanced, benchmarking has assumed a more traditional role in assessing and comparing practical systems in actual use. But benchmarking of practical technologies is different from benchmarking for decade scale research management. In fact, I would argue that in some ways they're opposite. For the decade scale technology development, we need efficient metrics that are aimed in the general direction of distant goals. Efficient means that you can try lots of things quickly, where quickness is relative to current hardware and software. The general direction means that better results are probably progress, even if the metric is too crude to validate actual applications, and even if the data that you use is biased in various ways. And distant goals means that we're not working on specific applications, though of course demo systems are always good. successful common task metrics for this kind of long-term progress can be very crude. So word error rate is actually in some ways a terrible metric because it implies that all mistaken words are equally important, which they obviously are not. The translation metrics that were first developed are basically just comparing bags of words in translation as if order doesn't matter and if things left out or put in by mistake don't matter. And it's easy to create examples where these metrics fail, perhaps disastrously. But at certain stages, especially early stages of development, they point in the right direction. Near-term technology evaluation needs metrics that are aimed at specific classes of real applications where the cost function is appropriate for the application. So word error rates and other word-based metrics now need to weight mistakes according to the effect on downstream decisions, or even create an evaluation that depends only on the validity of the downstream decisions. Accurate evaluation of this kind is task-specific, time-consuming, and often expensive. There's also an intermediate case where we just want to compare different algorithms or different parameter settings for a general class of now practical technologies. And except for the practical part, this is the same as the historical common task method. But I would argue that tuning a working algorithm using a long-established metric is actually different from devising a new metric to help us explore a space of solutions for a problem that no one now knows how to solve, or even in many cases knows how to frame appropriately. We need to do a better job of benchmarking human language technology research and development at all scales of time, all levels of task specificity, but I would argue decade-scale technology development requires a special kind of creativity in devising, evolving, and applying metrics, and funders, managers, and researchers all have a role to play in that process. So I'm done.
Excellent, thank you so much. And then let us move on to Ellen Voorhees from NIST, one of the drivers behind the Trek competition, which essentially got the whole idea of competitions in information retrieval started and goes on to this day. Ellen?
Okay, thank you. Do you no, you don't see me because it turned off. How about now? Can you see my screen? Can you hear me?
It says you've started screen sharing, but so far the screen is black.
Okay. I'm going to stop it and start it again.
Still black.
How about now? Oh, black.
Still black.
You know, I think you're probably sharing a screen other than the one you're displaying on.
Well, it asked me which one, and yes, I did have a choice, but I selected the right one. But let me stop it again. Now I can't. Now I've even lost my stop sharing. Okay, I'm going to try this one more time, and then I'll move on without the slides if I have to. Later, start. Share screen.
Oh dear.
Okay. So
okay.
It says double click to enter full screen mode. Why don't you try double clicking?
No, it's not working. Okay,
all right.
Never mind. I'll just wing it. So one of the things I want to say here is that I agree with pretty much everything that Mark just said. I have a slide in my talk that talks about co-opetitions. So that's this common task paradigm. I call them co-opetitions now because it's people cooperating, competitors cooperating. And that's largely what these shared tasks are. And these shared tasks have 5 main benefits. They improve the state of the art, they establish the research methodology, they form and solidify a community, they facilitate technology transfer, and then they amortize the cost of that. And I go into that a fair bit on the talk that's on the website. But let me, in this time, actually focus on some somewhat different stuff, which is how do you make a good benchmark task, right? Trek at this point has had, well, I guess I should say, for those of you who don't know, Trek is an evaluation of information retrieval systems. It was started as part of the Tipster program. Tipster was, Charles Wayne was the program manager of the Tipster program. Yes, so here on the slides that Ken is sharing, you can see at the bottom. Tell me which
slide to go to, and I will.
Yeah. Okay. On the bottom here is this all the different tasks that Trek has done throughout the years, and Trek has been going on for 30 years now, and we've done a lot of tasks. Most of them have been search tasks in one way or another, in which we include question answering. Right. We had a long period of question answering. The Trek in question answering ran for a long time, and we created lots of resources there too. You can go on, Ken. The whole point here for the co-opetitions is, yeah, okay, keep going. Just keep going. Okay, stop. Nope. This isn't going to work. Like 2 slides back. There. Nope. One more forward.
Forward.
There. Nope.
What's it good for?
Just stop there. One of the things that is different in the way that we evaluate search, and the idea of evaluating search on test collections actually started in the mid-60s, right? So this was really early. The problem with evaluating search on test collections is that you need the test collection, and the test collection actually has to say for every document, should that document have been retrieved for this query or not? And if you're going to make big test collections, that means a lot of human judgments, and of course too many for the size of the documents that you actually want. And so what Trek did, and the reason that Trek was as successful as it was, it pioneered the use of a process called pooling, which allows us to build these test collections at a much larger scale than they were able to be built before when Trek started. But that still means that you need to have, the way pooling works is you have to have runs from different retrieval systems to select which documents you're going to judge, which means none of the annotation gets done before the participants have submitted their systems. It's all after the fact. And that has a lot of consequences, but a couple of them are, A, there's this tension between whether or not you're producing a test set which only compares the current competitors or the current people who participated in the track, or you're building a resource for others to use in the future. So if you're building a resource for others to use in the future, then you need to make sure that that resource is fair to those systems that did not participate. The other major difference here is retrieval makes no pretense that there's a single truth. We know that people have widely different opinions about which documents are relevant. The same person will have different opinions at different times. So how do we create a evaluation structure on something that changes that quickly or that much, depending upon who you ask? Ken, if you can go on a couple more slides.
Okay, just tell me how many.
I don't know. Okay, stop there for right now. I'm sorry, I just lost my train of thought. There is no single truth, and so therefore we have to make sure that the evaluation methodology accommodates for this fact that different people have different ideas of what's relevant. And the way the retrieval community has done that is to say, yes, different people have different ideas, But if we use just one person's opinion for each topic, and we average that over lots of different topics, and then we compare systems, the comparisons are stable, even though the actual scores are not. And so we've gotten a lot of mileage out of that. That was true for question answering also. The comparisons were stable, even though the individual question responses were different from different humans. The other point I want to make here about building a test collection is you really do have to decide what it is you want this benchmark to be testing. And the more different things you want that benchmark to be testing, the more difficult it will be to build, and the more expensive it will be to build, and the less good of a job it will do at any one of them. And so you really, really, really do want to decide what has to be evaluated for this particular task and for research to move forward on this task. Because the more variables you have, the less power your benchmark is going to have. Along with that, it is imperative that the community whom you are serving and you, the builder of that benchmark, be really explicit about what you can and cannot claim with results on that test set, right? So the fact that systems can answer factoid questions from web documents, which is what the question answering track in Trek started with, doesn't mean that they have general question answering ability, right? I will claim that it is actually more question answering ability than just being able to find a token within a given document. But the types of claims that you can make over given benchmarks have to be acknowledged that they're limited in various ways, and they're limited because you had to do this abstraction in order to be able to say anything at all. And I'll stop there.
Great. Okay. Thank you, Ellen. And now we'll just have the final overview talk from John Massey. Again, as was a leader at Bell Labs, MIPS, Silicon Graphics, long history in both engineering and the whole industry. And so you're one of the founders of the spec benchmarking. So John, when you talk, I guess what I'll be particularly interested in is hearing what I saw towards the end of your talk, your reflections on how the early days of spec kind of seem similar to today's work in natural language. Please go on.
Thanks. Hey, can you hear me?
Yes.
Okay, so let me see if I can share screen here. Okay. You getting anything?
Yeah, it's good.
Okay. I have 10 screens, so it gets complicated. Okay, so unlike some of the other folks here, I might not be familiar, I probably am not familiar to most folks because the NLP work is completely outside anything I've ever done. Basically, I'm an ancient Unix guy, designed microprocessors, designed supercomputers, various other things, apparently coined the phrase big data a long time ago. But the reason I'm here, of course, is because of starting the spec benchmarking group. And if you're not familiar with it, I'm going to talk about it some, but the crucial thing is if you use a 32-bit or 64-bit microprocessor designed in the last 30 years, you probably have some influence of spec in there somewhere. Likewise, almost any Unix-derived system has been tuned up using spec. So that's kind of why I got invited to this. Okay, I'm going to talk a little bit about some early benchmarking organizations, but especially SPEC, although there's an interesting connection with the more recent ML Commons group that is going to be discussed in a later session. Apparently, a lot of us like Lord Kelvin. I couldn't resist the quote from him. And also from David Patterson, a recent Turing Award winner, about how benchmark shape fields, for better or worse. I would observe creating good benchmarks is harder than most imagine, although I think some of the folks here understand how that is. I'm going to sort of end up with the general issue of how you aggregate benchmarks. And there's a lot of ways that things can go wrong, or that things could easily be made to be better. So a bunch of benchmarking organizations got started in the 1980s and 1990s. ML Commons, as I said, is a more recent thing in the last couple of years, and it was partly inspired by SPEC. I got grabbed by Dave Patterson to sort of come and help talk about SPEC experiences. Most of these things are funded by the corporate members, but there's crucial interaction with academics. So SPEC is basically there to do, well, it started with CPU performance, but it's branched out into other areas. It's got 5 groups, and some of these groups have small subgroups of one kind or another dedicated to different areas. So in some sense, SPEC has become a bit of an umbrella group. At least 2 of these groups originated outside and then decided they'd like to be part of this, and it amortized the structure, and they liked the way things were done. This is what it typically costs. It doesn't cost much to be an associate, which is what the universities do. Most of the money comes from the corporate members. This is an example of one of the groups within there. As you can see, a lot of computer companies, and the associates are mostly universities. When things get voted on, the members get to vote, but the associates can be pretty involved if they want to be, to make comments and make suggestions of benchmarks. So here's the current benchmark categories. Again, it started with the CPU benchmarks in 1989, and they've updated those multiple times. There are other ones, and there's some interesting overlaps with power, that being a fairly crucial thing these days that wasn't there back then. And importantly, there's 30 sets of benchmarks that have actually been retired. I would suggest the willingness to retire benchmarks is pretty important. Okay, so there's a pervasive issue that came up for not just for SPEC, but I think for other ones. People want to see individual results and select those that are most relevant, but they also want summary numbers, and that can cause trouble if you don't do it right. This was an example of the kind of performance documents that companies put out. There were a bunch of benchmarks that sort of had to be talked about because they were industry standard that a lot of us didn't think were very good. So, I typically wrote this document, and I suggested, we use some real Unix programs to get integer performance. Because they are ratios, we use the geometric mean, and I'll talk about that a little bit later. And then there were things like Drystone that frankly were terrible benchmarks, but widely used. And then there were a bunch of floating point benchmarks. They were better. There were published MIPS ratings at the time that everybody used. The trouble is they were incommensurate between vendors, so you couldn't compare things. So SPEC started in a really weird way. He was a prolific writer for EE Times magazine. He used Drystone MIPS, that is performance relative to VAX 11780, on a really simple, dumb, small benchmark. I complained to him. He came back saying, so why don't you folks do something better? And he owned a bar in Campbell, California, said he'd give us beer and we could have a neutral meeting place. So I collected some other folks. Turns out we all weren't very happy with the state of the world in benchmarking. We wanted to codify good practices, and these are kind of similar to what other people have described to be successful. We had a year of really hard work. We released the first set of benchmarks in fall of 1989 after collecting other vendors besides the four who started it. We wanted to have two separate summaries for integer and float because we knew they were different, but we got big pushback from press and other people saying, you know, if you're going to get rid of MIPS ratings, you got to have just one number. So we did that. Well, what the vendors quickly did was publish them both anyway. And by 1992, we fixed it. The sort of funny thing is one of the press asked us, hey, you know, isn't this being done by computer companies and letting the foxes guard the hen house? And the answer was, hey, nobody's better than a fox at keeping the other foxes from eating the hens. And this comes back to Ellen's talk about co-opetition. Even with ferocious competitors, and believe me, that was a time of fierce competition, I think it can work pretty well. People find it's better to be in there than out, but that it also gets rid of complete duplication of efforts. So pretty quickly, we collected other vendors. And skip this is why we picked the VAX. There was a lot of arguments about how you aggregated data. I know there were so many papers written on this. It's unbelievable. Turns out, since we converted everything to a common reference, that is performance relative to the VAX 11780, and it could have been something else, but that at the time, that was always treated as one by almost everybody. Anyway, it turns out that once you get to ratios, you need to use the geometric mean, or you get inconsistent results depending on which machine happens to be the denominator. And that actually got used in what were called ratio games, where people picked the denominator very carefully to make themselves look good. But you know, here was a simple example where you could prove either machine was faster. And we couldn't have a methodology that favored any one machine. Well, a bit later on, after I'd essentially retired, I looked some more and realized that the usual way to compute a geometric mean was the equivalent of converting things to the ratios to logarithms, taking the average of that and then exponentiating it back. And that said, oh, this is really a statistical analysis on the logarithms. And, you know, in many areas of science, people do transforms on the data, logarithmic, inverse, sometimes square root, and a couple other ones. It's a standard thing to do, hoping to find a transform that gives you a normal distribution. So all the great properties of the normal come up, right? And you know, the one big message here is one ought to at least, if one is going to do any kind of average, one at least ought to do the other of the first four moments. That is the standard deviation, skew, and kurtosis, and figure out whether or not the mean is a decent representation of centrality. So I wrote a paper on this, and then I gave a talk a lot of places. So I maybe take a few lessons for NLP, and I know nothing about NLP benchmarking, so I rummaged around, found some quick things. Obviously, a huge space. There's probably some overlap with ML Commons, but maybe there's some general lessons from this. I particularly looked at glue and then super glue. That seemed to be pretty reasonable things. There's 8 benchmark test sets and an average for single figure of merit. And this reminds me a lot of spec in the early days. I did have one question here is the super glue paper very nicely showed how things varied on in different cases. I worried a little bit that since these things were ratios versus humans, that the proper average is the geometric mean, and I wasn't sure whether that was used. I couldn't tell from a quick look at the paper. So I noticed there are leaderboards a lot, which are pretty nice, but I worry a little bit about this because, again, my default is, and the reason I did this talk called Summarizing Performance is No Mean Feat. The idea was you want to look at the other moments of the distribution to know whether the mean means as much as you think. Okay? So what I did just for fun was to take the top of the leaderboard and do the other moments. And, you know, there's a pretty large standard deviation for the humans, right? They're all slightly negatively skewed, right? This says, the kurtosis says it's not too far off from normal. I got scores here, but I noticed that, for instance, although Ernie has in fact, all three other ones have a better score than human, they're actually not better on 3 or 4 of the benchmarks. And in fact, what it seems like is that most of the difference is the human bad performance on multi-RC. And if you take that out, they're not better than humans. So the worry here is that sometimes numbers like this can be overinterpreted. I always had this fight in spec of how many digits of precision people showed. Okay, so quick lessons here at the end. You know, when the field is fast moving, there's a lot of benchmarks and metrics. They're likely confusing to people. It's possible to do good benchmark efforts, but it takes work. Like Ellen, co-opetition really works, but people do have to be reasonable and develop trust. I think from history, what's clear is efforts that start small and focused and then do extendable processes tend to work better. Trying to do everything at once is hard. Sometimes these groups act as umbrellas. No one group can do all this. It really depends on the structure of the domain. I think it's really important to have industry and academia involved, and sometimes government. This issue of individual benchmarks versus summaries. We always found in spec, some customers would come to us and say, well, I'm glad to see the overall numbers, but we know our work really relates to these 2 benchmarks, and we'll just ignore everything else. And we were happy. But a lot of people, if they didn't have that knowledge, just you know, wanted to see the summaries. Okay? Anyway, real hope is a little more analysis of distributions, not just averages. And we got to apply, you know, good, simple statistical methods to calibrate what we know. So looked to me like superglue was pretty interesting. Obviously, one would like to have more benchmarks and better statistics for coverage. And I think one of the superglue folks is here, so that ought to help. Okay, that's it.
Okay, thank you very much, Sean. So in the participants, if you just would raise your hand if you have a question. While you're thinking of your question, I'll start with one for our first 2 speakers. Why do you think the so many people were convinced that higher level knowledge was necessary? Was it simply because what they were doing wasn't working, or did they actually have good scientific reasons for thinking that?
I think both answers are correct. That is, what people had tried to do up through the 70s wasn't working, but also just thinking about things and asking, how do you know it was this word rather than that word that someone said on a particular occasion? It's because, well, that makes sense. Okay. That's what it would have probably meant. So
yeah, one thing I wondered if people knew then what we know now, like for example, hidden Markov models, could they have done the work, or were like computers just not up to it and data sets just weren't big enough?
They could. Both were true. They could have done better, but computers weren't fast enough, and they didn't have enough.
Ken?
Yeah, so I wrote an introduction to a special issue on corpus-based methods in '93 with Bob Mercer. And we thought quite a bit about this question. And at that time, I think we kind of concluded that people think about what they can afford to think about. So the people that were in well-funded industrial labs were using the kinds of methods that John was advocating. And the people who were in less well-funded academic labs were not using those methods. And I think it came down to money.
Okay. Pedro?
Yeah, so there were great talks about kind of tracks and the DARPA program. I'd be curious to hear about the relationship between the two. How did they collaborate or not? How did they influence each other? Since there are people here that were part of that.
Okay, my camera has decided now to not turn back on. So this is Ellen. I'm not sure though I understand the question though, Pedro. How did the individual tracks interact with each other, or how did Trek interact with something else?
How did Trek and the DARPA programs interact and influence each other? Because they seem like they have a lot of similarities.
Okay, so yeah. Trek started as the evaluation arm of the Tipster DARPA project. So Tipster had three main focuses. One was on retrieval, one was on summarization, and one was on information extraction. And Trek started as the evaluation of the information retrieval part of that. And it actually started because Charles Wayne came to Donna Harmon, who was at NIST at the time, and asked her to build a test collection for the DARPA contractors to evaluate their search systems. And she said, well, no, can't do that for a variety of reasons, but we can form a large test collection and convene a workshop to have people discuss how would we build such a large test collection. So that was the genesis of Trek at its very beginning.
It's worth saying, pointing out, Ellen, something people may not realize was that, which is that all this was happening before the internet really existed.
Right.
And certainly before there was a lot of available text data. So Brian said, well, text is easy, speech is hard. In those days, everything was hard. And the first collection that Donna wanted to put together, she wanted to study information retrieval at scale with a collection of as much as 1 million documents. And that looked like a very, very difficult thing to do in those days. And we were rescued by Peter Brown, who was then at IBM and who learned sort of through corridor conversation or something that an IBM group in North Carolina had been subscribing to the Federal Register for 20 years and had been keeping all of the, those big 9-track digital tapes. And so Donna put him in touch with me, and I said, well, send them to me and we'll make them available to everybody. So pretty soon a semi-trailer pulled up and people began unloading cardboard box after cardboard box after cardboard box full of 9-track tapes. There were so many of them, I stored them in an unused office, and the building manager pointed out that it was violating the capacity, the load capacity of the floor, and the building was going to collapse unless we split them up among several offices. And I won't bore you with the story of how we turned that into something that could be distributed and finally distributed it. But in those, there were a lot of hills to climb in order to get to Trek.
Great. By the way, Pedro and Ken, I see you still have your hands up. Do you have another remark?
I do.
Okay, Ken.
So I thought a kind of unifying theme that I heard in John Massey's talk, but also I think in almost every one of these, is that there were certain key people who were really essential to making this happen. And I worry that, and some of the things he was talking about, like the organization, I don't think that benchmarks like glue or even the things that are on papers with code have a kind of living organization that would help add new things and retire old things and allow personalities to be influential the way that some of these older mechanisms worked. So I'm thinking here, we've mentioned Charles Wayne a few times, and I'll bet there are half the people on the call probably don't know who he is. And it sounds like in spec there were a couple of key people. Maybe we heard about the bar owner, but you know, it's I fear that we don't have that right now. These things get embedded into the literature, and then once they're there, there's no way to retire them, and there's no way to uncover the flaws or to address the flaws. And even trying to publish on the flaws is quite difficult. Some of these benchmarks are worse than probably the bad things that John Massey mentioned, and they're still being published on, and many people don't even know about the flaws, and you probably can't find the flaws documented anywhere.
I just a response to that is certainly there's been some really there's a lot of work now on so-called common sense reasoning, so the kind of question answering from general text, and numerous work, I think particularly by Eunsol Choi and from UW and others from the AI2, continually showing that the benchmark data sets can actually be solved by just learning the biases in data set as opposed to actually answering the problems, and then they try to refine the data set to get rid of that bias, and then it pops up again. And I was just wondering if to what extent is that sort of a serious problem in this whole enterprise, that once we go beyond speech recognition, is this issue of biased data sets which allow sort of non-progress while appearing to do better on the benchmarks, really a critical problem.
So I think that it is a critical problem. This is Ellen. For instance, any benchmark that you create, any data set that you create is going to have some peculiarity that is not particularly germane to the task at hand. It's just the way the data was collected, or what was available, or you know, any number of things. And that's one of the reasons why you don't want just one test set. You have to have more than one, because the entire community is then going to overfit to that peculiarity. But I also, I'm going to give a plug here to myself. The TREC questioning, the TREC question answering sets really did answer. I mean, was an actual question answering task, and not a fill in the blank, and not a mask, and I really think that is a significantly better representation of a question answering task than what's is now being called question answering. So another point in building these data sets is that you're going to have to really be clear about what it is that you're testing. And actually, the original squad paper did do that. The original squad paper did say that they were using crowdsourced extractions just so that they could have the evaluation, right? Some of these decisions get made because you have competing goals and you want to be able to have automatic evaluation. That's going to be very different than if you're not going to have automatic evaluation, right? So there's a lot of competing things in here, but there's also a lot of claims being made on existing data sets that are just flat out fantasy.
Lori, do you have a comment?
Yeah, sorry. I also meant to clap. I was having trouble with the reactions buttons. So I do want to clap for what Ellen said, but that wasn't the main thing I meant to do. So following up on that, I guess I have a question going forward about what we need. I see a lot of benchmark evaluation sets being produced very quickly for shared tasks and or very quickly under limited funding, and not enough pressure from the community to prove that your data or task, I mean, we're sort of looking under the lamppost for a lot of things. Like, okay, CNN Daily Mail has these little blurbs. Let's use those as human summaries. So that's sort of looking under the lamppost, not asking, are these is this the right data set? So what influence could we have on, say, funding, say like the National Science Foundation in the United States, to treat benchmark creation as a science? I'd just like to hear from any of the speakers on that.
One positive development, or at least I consider it a positive development, is that a lot of conferences are now going to have data and resources tracks. Because prior to these data and resources tracks, it was frankly impossible to get a paper accepted if what you were doing was describing a resource or why you built something. I mean, I shouldn't say impossible because I actually have a couple, but it was really, really hard to write about what it is that you did and why you did it and get it published anywhere other than the TREC proceedings. There's lots of things in the TREC proceedings, but that's not helpful to a broader community. But there are now these resource tracks, right? NORIPS has one this year, and I think they had one last year. SIG-IR started one this year. That's a positive sign. But you also need people, general researchers, to care. And we're sort of, if you are at this workshop, then you are not the generic researcher. And so I'm not sure what to do about that problem. So,
well, maybe I can put in a word from the NSF side. I see we're about a minute over time, so this might have to be the last comment, which is that we're really interested in funding data as infrastructure through our infrastructure programs. So if you have ideas about how you want to sort of go into this science of benchmarking and do a better job, really dedicate serious research and time and effort to it, please don't write that off. You can actually get money for that. So particularly if you look at the CCRI program, contact a program officer there. They like to start with a planning grant. So a grant that you could do for like 6 months to pull together the people who are going to work on that. And then you could go, after a several $1 million grant to really build something substantial for the community. Ken, should we stop right there?
No, actually,
okay,
the calls go on much more than an hour.
Okay.
They're
Sorry.
nominally 90 minutes, and we can go for 2 hours.
Okay. Oh, great.
No, I don't know if you allowed that, if your busy schedule allows for that, but I think we would like to keep going. Yeah.
Okay. Oh, definitely my schedule allows. So.
Right.
Yeah. If we're going to keep going, I'd like to reply to both Henry and Ellen or ask follow-up questions. So for Ellen, I have been reviewing in the resource and evaluation tracks, and the stuff's not good. And I think that we need to set a higher standard for what's published in those tracks. Maybe, I'm not sure if just a few good examples need to be published to put everybody else to shame. And then for Henry, my question is, the CCRI is really pretty big grants, but so the areas that I apply for NSF funding in are linguistics and IIS, and they don't And, if I call a program manager and I say, I want to create some data, unless it's endangered language data, which they do fund, they say, we don't fund data creation set. End of story. That's it. No small grants. So there's just these really big CCRI grants, but there's nothing smaller available.
Let me respond to that. So what is it that you're looking for in a resources paper?
Yeah, so as I said, usually people are, a lot of the papers are looking under the lamppost. They're saying, I created this resource because I could. Some of them have, I guess I'm looking for a bit more, like, why is this sort of like more reasoning that this is a good evaluation for this task. And I'm not seeing that level of reasoning in the papers.
Okay, so let me just actually, before we, I see we still have Ken and Pedro again with their hands up. So in terms of funding mechanisms, you might be having had bad experience in the past with mid-scale. So mid-scale infrastructure, which tend to be very large. CCRI, the planning awards are 50,000 to 100,000, and then the medium awards are 2 million to 5 million. So these are slightly bigger than an NSF small, but of course, but they're not huge. And I would also encourage you that if you are getting messages back that your work is not fundable because it's about developing a resource as opposed to using that research source to do novel research, please take it up the level. Take it up to the level of the division director, and if you don't like their answer, take it up to the AD, who would be Margaret Martinosi, because I mean things really are changing. We have had a lot of turnover, and there really is within the last I'd say the last year essentially this change of thinking about infrastructure. Ken?
Yeah, so I'm thinking if we look historically at what Charles Wayne did, and I suspect John Massey knows historically much more about what happened in that community, that there were certain individuals who were thinking very long-term with a lot of strategic vision. And they were, I think they're looking more than just, when Mark described how to set up some kind of a program that would actually survive for decades and benchmarks that would be relevant for a while. And I worry that the mechanisms we're talking about right now, like an NSF grant or a paper in a conference venue or something, or what goes on really practically is, say papers with code, that this isn't getting us on a long-term strategic vision. That is, each of the little steps that, say, John was talking about with resource management, it was part of a bigger roadmap. There was something, some people behind the scenes were, and I think that I don't think Charles did this all by himself, but I think he was talking with most of the leaders of the field, and they came to some consensus about where things should be going. And they worked out a plan that was quite viable and doable, and they did it. Now, when I got to know Charles a little better when I was at Hopkins, I got the impression that he did a lot of these things without a lot of support from his management. He was pretty much on his own. And then I think that after he's, when he retires, and if he's not there, I don't know that there's anyone to really step into that place and do what he did. And I think that it really, all this history we're talking about, I think it really does kind of depend on a couple of individuals to make it so. Anyway, that's my soapbox, and I would love for someone who knows more than I to tell me no, 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 and we can do just fine. But I think that I'm kind of scared about the future because I don't see that kind of strategic vision in what we're doing today.
Well, one thing I can say is that if you look at the physics community, they've kind of got it figured out, where very senior, powerful people in the physics community move into strategic positions in the federal funding community. And it's pretty rare for that to happen in computer science. Pedro. Oh, Pedro, do you have your hand up from before? Or do you have a comment?
I had a separate question. So if there's more discussion on this, then can continue.
Yeah, I think
okay, before that, then I can just say to Ken's question. One of the benefits that I claim for long-running co-opetitions, such as Trek, is that the individual tracks, that is where planning for this field gets done, right? So within, say, I don't know, let's use cross-language retrieval, right? That was a track that ran the data sets that get created, enable the research in the field, and it attracts the people, but also the actual meeting itself is where people get together and talk about, is this the way that we should be evaluating this, and is this working, and do we have the right data, or do we not have the right data, and what's the problems? And so I don't think it is as bleak as you're currently saying. But I do think you need that critical mass, and you need the community input. It's not going to be one person. It's not even going to be a steering committee that's going to decide all these questions. It has to be, if for no other reason, you need buy-in from the community in order to get participants, right? So it has to be this sort of collegial, are we doing the right thing, and why not, and where should we go if not, sort of stuff that happens.
So I think you're absolutely right. And I think that, Donna and you did a great job with Trek, and I think Charles, put together meetings for a lot of other benchmarks. I'm worried that that's not happening with glue, and that, say, John's quite serious criticisms of glue are probably not going to be heard by anybody who's in a position to do anything about it. And as for what Henry said about physics, I had an experience where I was on an NSF panel, area interdisciplinary, and physics was definitely there, and computer science was there. And there was no way that we could support the computer science proposals because the physics guys just work so much harder to put together their proposals. And the reason is because the computer science guys have too much money, and that the money that was at stake here just didn't matter. So it was junior faculty in computer science up against the best in physics. What are you going to, the results are, there's nothing to be said, say no more. Anyway, yeah, so we're probably slopping this off, and other fields are doing better at it because perhaps we're just not hungry enough. Anyway, I'm very worried that if we don't get this right, we will be hungry enough.
Okay, but I said it's not just at the lower level. Actually, but when we talk about the really big, the big investments,
yeah, it's the same deal.
And you see around quantum, they've been so well organized.
Right,
it's the
same deal. The physics guys are together because they have to be.
Yeah,
right.
Yeah. Pedro, do you want to change the topic?
Yeah, so I had a follow-up question around question answering and formats. So Squad did the span thing because it's easy to evaluate. evaluating free text has its own challenges. Like you might disagree on whether free text is correct or not. So I was curious to kind of hear like what are different ways of going about like a different format, or like we should be fine with having like humans evaluate a smaller set of examples rather than automatic and just have like big tech companies pay for it because it's not that expensive. So I was kind of curious to hear about this topic.
It's not that simple, right? One of the reasons why information retrieval, straight document retrieval, the data sets that got produced there were so impactful is because people could then take them away, as Mark said in his talk, and do their own hill climbing in their own research cycle. The data sets that Trek produced for question answering looked superficially similar to that. We had human assessors make judgments, but in fact, they didn't have this property of being reusable because you could have taken an answer from anywhere in the collection, and maybe that answer was correct, but no human looked at it, and so your system wouldn't know that. And what we tried to do, and what we did do in Trek in that case, was we created regular expression patterns and for people to use after the fact. And if the regular expression pattern matched your string, then it was considered correct. Now that's clearly much noisier than having a human look at it, but for the level of effectiveness that the systems were doing, it was sufficient. So that's another really good point that Mark made, was that the data sets and the measures that you're using are all relative to the current state of the systems, because things which seem sensible are probably fine if the systems aren't so good, but as the systems get better, you need to be able to make more fine distinctions, and so your measures have to get more sensitive. And so I will continue my diatribe from earlier this morning on question answering evaluation to say that what I really think when people, it annoys me terribly when people say that they've reached human performance on question answering, because what they've really done is they have hit the measurement error, right? All they're doing is they're within the measurement error. That is not human performance, right? That's measurement error. And you don't want to celebrate measurement error. So you have to decide in creating the benchmark, is what you're using good enough to distinguish the types of behavior in systems that you are looking to be able to distinguish. And that is far more, that is not necessarily purely science, right? There's a lot of art into trying to create a data set that will make the distinctions that are important and not make the distinctions that aren't important. And you probably have done this without enough information, because if you knew how to create that data set in the first place, you probably have already solved the problem you're trying to test. And it's not, and once you do all that work, it's not going to be forevermore, because the technology is going to change and the language changes, and et cetera, et cetera. And so benchmarks also have a shelf life. Depending on how you make it, that shelf life will be longer or shorter, but it does have a shelf life.
So I'd like to perhaps follow up on that, but sort of take it a step further to suggest that that most of our benchmarks today are pretty irrelevant in the following sense. If 10 years ago you were buying a PC, you looked at the reviews and they were full of the different spec numbers. And of course, if you look at a review of a computer now, there's rarely any of that kind of data in the review. They talk about how long does it take to transcribe or to, let's say, convert a particular image in Photoshop or video in Premiere, whatever. So looking at the sort of end-to-end task, because that's what people care about. They don't care about the numbers. They care about getting the job done. And if you talk to most people in terms of what they want to do with natural language, is it's not one-shot question answering. You want to have a conversation, back and forth with a conversational agent, and you can have clarifications and sub-dialogues and all that kind of good stuff that people were talking about in the dialogue community 30 years ago that seems to have kind of vanished now. And so we have Siri is just as bad as it always was, and Alexa are just as bad as it always was, even though on the benchmarks we're getting better, because the benchmark is sort of based on these little micro tasks, one exchange. And I just wonder if there's any response. Is there serious work now on this, of looking at benchmarks for extended conversations and actually solving a whole series of sort of natural everyday tasks that require extended communication in natural language?
Well,
I don't know if
yeah,
Pedro,
there's a fair bit of work on conversational assistance sorts of tests, right? Trek has one track on that, but there's others out there. So these are the types of questions that one asks your favorite Siri or Alexa or Google Home or whatever, but but not just one-off questions, right? Sort of a series of questions that relate to the same task you were trying to accomplish. So there are some data sets that do that. There's also a bunch of dialogue data sets, but I don't know very much about those, and I'm not sure what they've even tried to do. So I know of their existence, but I don't actually know what they do. So maybe someone else here knows more about. I'm not sure someone else here does know more about those.
I see Ken put an interesting comment in the chat. Is that chatbots are hot now, but the metric is how to keep the conversation going, not how to solve the task. Exactly. And the other is, I did some analysis on logs for systems like Siri. Anything that took more than a single turn was almost like surely to fail. And again, that's certainly my experience as an ordinary user. Ken?
Well, yeah, I mean, you read my comments. I don't know that I have more to say. So I believe there are data sets out there about chatbots. Like, a lot of these are kind of like entertainment, but they're almost, romantic stuff. That is, there's a lot of lonely people in the world, and they've now got AI systems. It's sort of like the old ELIZA system, the people who want to talk to somebody and spill their guts, and it's almost better if it's not a real person, because you don't have to worry about, whatever you'd have to worry about with real people. And these things seem to be incredibly popular. You can actually make money keeping this going, but all the research is how to keep engagement going. I mean, people are saying that, like with social media, the reason that you get into this sort of weird dynamics where controversy sells better than being sensible is because the metrics are all about engagement. They're not about actually accomplishing something useful. And so I think there's an opportunity here, but I just worry, my experience was that any of these tasks that you wanted to do with like a Siri-like thing, if it required filling out a template where there was more than one slot, there was just no way to get it going, to make it work. A form works pretty well on a phone or on a website, but to try to do the same thing through a dialogue seems to be very, very hard. Now, maybe somebody on the call can correct me, but I don't know of anything as simple as a web form that works in dialogue. Yeah.
I don't see anybody responding, but perhaps that's where we should be putting more effort. I said that I'm driving in my car. I've got to use voice. I'm not going to start, and I want to actually again have a little conversation about let's go find a Five Guys on the way because I really need to get one of their shakes. I can't do that. John Dubois.
Yes, I really like this discussion, and I don't have a solution, but I have been talking to some people in industry about trying to create a benchmark that would get at this concept of a extended conversation. And I think there the the challenge is problem solving over an extended period. So in other words, not just engagement, but I definitely have felt the same issue of the one-off question that things seem to be stuck in a loop where that becomes the measure of all things, and it's people have gotten very good at that, and it just seems to leave you with really nothing to say about extended conversations. So one thing I'm wondering about is if one could take real extended sequences and treat those as something to be tracked or analyzed, or if one could, let's say, label each move as, what does that move do? In other words, okay, here we have a clarification question. So at least if systems could adequately label a sequence of 10 moves from a real conversation, maybe something like that could become a measure.
And that's, again, that reminds me so much of, again, what people were trying to do manually, back in the 70s and 80s. And data sets were created, but by today's standards, of course, they're tiny. So think if could we come up with more self-supervised and semi-supervised methods for labeling these kind of extended conversations. We have so we're heading up on now the 90-minute mark, and which I guess is the official end. So should we just completely change topic? Then we'd like to jump in with some other thoughts.
Can I just add to answer John? That is precisely what the conversational assistance track in Trek is doing. It's taking the coordinators of the track, so it's not directly taken from search logs, but the coordinators of the track have taken inspiration from search logs of real places and created a series of on the order of between 5 and 8 questions, all related to the same thing. We have not tagged the questions about what speech acts they're trying to accomplish. It's just here's the set of questions. The track has offered different sets of documents for people to get answers from, or you can do it end to end. And the track is in its 3rd year, but it's clear from the first 2 years that systems are really very much worse at the moment of answering subsequent questions than they are answering the first question. And that's all for all the reasons that you would expect, right? It's an AFRA, and if you get it wrong early, then you're hosed completely for later on, and all those sorts of issues.
Thank you. That's encouraging that something is going on.
That's great. I'm going to immediately go look at that track. Any other? From Neville. Neville, do you want to say that question yourself rather than just put it in the chat?
Yeah, sure. You hear me?
Yes.
Okay, good. Sorry, my microphone setup is rather more complicated than usual today. Yeah, so I just double checked this. So the current Alexa Prize Challenge does have a TaskBot challenge where the focus is not on social engagement, but actually solving a specific task. I'm not participating in this challenge, and their website does not provide a lot of information. I don't exactly know how they're doing the evaluation, other than just saying there's a panel of judges that judges what bot wins in a bracket-like competition. But at least the focus is on a goal-directed task as opposed to just continuing a conversation and producing output that sounds more natural than what previous generations of chatbots did.
Great. That's good. That's another thing to follow up on. I'd like to put in an advertisement at this point in the proceedings. My division, IIS, is looking for 2 program directors, one for robust intelligence, which is, funds our human language technologies work, but we're looking for, sort of a general expertise in AI, and another for III information, which is sort of more of our informatics across a wide variety of domains. And there's also a search for my successor, which would not start until June 2022, but they're taking names through October. So this is the most fun a person can have who is of a certain age. So if you are of a certain age or know somebody who is, and you'd like to get them the heck out of your university, please encourage them to apply for the DD position. And if they aren't old enough, but you just would like to get rid of them, send them to us as a program director. Thank you. Back to you, Ken. So would you like to continue on longer, or should we draw to a close?
Well, I'm happy to stay as long as people want to stay, but I don't want to overwhelm, people. We've been going, some of us have been on this call for quite a few hours now. How do people feel? Have they had enough, or should we keep going? Maybe we're kind of running out of energy here. I think this has really been quite wonderful, and I hope the GitHub and the YouTube videos will stay up forever, as far as I can tell, I think this would be good if it could evolve into something more long-lasting and constructive. Somebody suggested that maybe this YouTube channel will have enough followers at this point that it could be used to do something, especially if you guys submitted content or something. We should be thinking about next steps. Where do we go from here? If we wanted to have the kind of strategic thinking that Ellen mentioned used to go on at the Trek meetings, and I think Charles used to do at Hidden Villa meetings or whatever. There was, these meetings that he used to hold, and there are, I'm sure, the bar and that Spec used to be held at. I don't know if we can afford to do a physical meeting in this time and age and so on, and especially, but there must be a way to somehow keep a discussion going where we can kind of find out. I'd like to do something better with the benchmarks going forward than just have them end up in the literature and nobody knows about it. One question I'm kind of concerned about is Pedro, I think, mentioned that he didn't know about all the stuff going on in Trek and other places like that. I think that there's stuff going on in web search, like at Wisdom and so on. My guess is that the venues have gotten very insular right now and maybe a bit taken over by machine learning, so that if you want to do anything that involve, people wouldn't know about the history or what goes on in other venues, or that I think web search is perhaps better at collecting data that's relevant to web search than our community is. Q&A is kind of a made-up problem. So I don't know. I mean, Pedro's question really bothers me, that someone in our community could be working today and not know about anything at DARPA or Trek.